advancement in energy efficiency and resource recovery. The company's initiatives align with the global emphasis on sustainable practices in the energy sector. What do you know?
Thank you, sir, for your nice introduction. So, myself is Dr. Sankararao. Today, I am going to discuss about green hydrogen generation technologies, challenges, and opportunities. So, my talk is mainly divided into three parts. One is what is hydrogen? What are the challenges is there to generate the hydrogen? And what is the commercial applications? And along this sector, what nanosolutions mean? These are the three parts. So already speakers have explained about what is the green hydrogen and the green hydrogen technologies. So what is the main advantage of this green hydrogen is to minimize the greenhouse gases and to enable the large scale energy storage. Compared to batteries, we can store in the large scale energy storage, and the future is completely avoided with the hydrogen. So why hydrogen is important? Already there is a number of fuels are there like cow dung, wood, coal, petrol, kerosene, diesel, LPG, or methane. Whereas compared to this petrol and yes. If you take this petrol, where is the calorific value is 44 to 46, whereas the diesel is a 42 to 46 megajoules per kg. Whereas the compared to hydrogen is nearly 122 to 142 megajoules per kg. So compared to existing fuel, it is having 3 times of the calorific value, and in addition to that, it will emit a byproduct as the water vapor, whereas in a use case. So that is because of this peculiar property. So people are across the globe it's looking towards the hydrogen and to replace the existing fuels. So what is that? Along with that, compared to battery, it have a fast charging like a CNG. It will take 3 minutes or 5 minutes for refilling, and it is a clean fuel with zero greenhouse gas emission. They have a huge number of applications right from that industries, transport, domestic applications, and it have an excellent calorific value, and these are the viable properties. So what is the challenges is there? There are technologies are there, but hydrogen is not a primary source. So like a petrol or diesel or something, once you go into the underground operations, and you can when a different melting or boiling points, you can get the different source of the liquid fuel. Whereas this hydrogen, always it is available as a secondary source. It is not a primary source. So you have to develop the technology where you have to take the hydrogen. So hydrogen is associated with the water. So you need a technology to break the water. Hydrogen is in the ammonia. You need a technology to break the NH bond. Where hydrogen is with a methane, CH4. You need a technology to break the CH bond. So that is the main thing. So where it is associated with water, methane, ammonia, and methanol, ethanol, all these things. So these are the things. And in addition to this, it has a, in addition to that, hydrogen production and transportation is also necessary, and storage. There is a storage also, people are storing for that different stages, like a type 1 cylinder, type 2 cylinder, type 3, and type 4. Type 4 is the metal hydrogen based cylinders. So now people are working on this sector. And if you take all this sector, so all are in the nascent states, are in the lab scale stage and research level. So in future, the government of India and along with many other companies are actively working on bring this technology from the lab scale or research level into the real time applications. So this is the hydrogen roadmap, where is the production technology and storage and transportation and application and associated aspects I will discuss in future. So this is the production of the hydrogen. So hydrogen is not new to the market. So hydrogen, green hydrogen is the we want to replace the green hydrogen with the existing fuel. So already hydrogens are mainly classified in the previous speaker thing also explained about black hydrogen, brown, gray, blue, and pink hydrogen. So based on the source and based on the process, the hydrogen color of the hydrogen will be decided. If you are along with the steam methane reforming, in India many people are using the SMR process without a no CCL, and it will that hydrogen we can call it as a gray hydrogen. So why need to replace this brown hydrogen with gray hydrogen, blue hydrogen means? So during the production of 1 ton of green hydrogen or gray hydrogen, it will emit 11 tons of carbon dioxide. So whereas if you produce the hydrogen from the coal by using the gasification, it will emit 19 tons of carbon dioxide to generate a 1 ton of hydrogen. So because of these properties, so if the hydrogen, if you generate gray hydrogen or blue hydrogen, already it is emitting the carbon dioxide. So people are want to replace this gray hydrogen or blue hydrogen with the green hydrogen, where it will emit zero greenhouse gas emissions. So because of this peculiar property, people are looking for this electrolyzer and green hydrogen technologies. So this is the one of the best advantages of the, like whether you can take the electrolyzer, whether it's a sperm electrolyzer, ADM electrolyzer, alkaline system. So whatever it may be, based on the process and based on the source, the green hydrogen will be there. And they want to minimize the cost from the at present around $4 will be there. By 2030, they want to bring into the $1. So this is the complete hydrogen economy. Right from this solar or wind energy as a power source, and already the previous speaker explained about the stack like a hydrogen generator. So where it is a different components will be there, like a membrane, membrane electrode assembly, end plates, flow plate, current collector, monopolar plate, bipolar plate. So I'm the feature one. And in addition to this is a pipeline for hydrogen transport. If you want to use the hydrogen in the refinery or fertilizer or steel industry sector, so you have to develop the large scale pipelines. So because you cannot produce on-site generation for that refinery required hydrogen. And in addition to that, we can replace all that telecom towers in India is run with a diesel generator, a DC set. So that we can replace the diesel generator with this hydrogen by developing the hydrogen storage. So hydrogen storage, there are type 1, type 2, type 3, type 4 cylinders. Type 1 cylinders is the metal-headed cylinders. There are type 4 cylinders, 6 to 8 layers of the metal cylinders is the type 1. Type 4 is the metal hydride cylinders, where is the carbon coating will come on this one. So very few people are working on this hydrogen storage up to 700 bar. And whereas if you can go, you can use directly for the gas power plant. And whereas this application for the fuel cell vehicle or transport sector, where you can like a CNG. When we are working in the 2009 on the CNG, now into 5, 6 years, 3, 4 years back, only we are seeing the CNG vehicle on the road, a full-time vehicle. At the same time, where we are working in 2009 on the CNG. So this is the next one is that dispensing system. So in future in India, across the globe, only 1084 hydrogen refilling stations are there. In India, commercially only 2 fuel refilling stations are there. One is in IOCL Faridabad and another one is in the Ladakh. They are working and they are tied up with the Ashok Leyland and they are developing some fuel cell vehicles. These are in Leh. And if you generate a huge number of huge amount of hydrogen, you can export the hydrogen by using the nearby countries or through seashore, like converting this hydrogen into ammonia or methane and other forms. So you can take this is the complete hydrogen economy. Whatever the sector you touch, it is all in the nascent stage, and still the government want to push this one into the next level to export to the all these sectors. So the hydrogen generation technologies are that is the first part of the basic introduction. And the second one is that hydrogen generation technologies, as a previous speaker said, that hydrogen is not new, but we are adapting the steam methane reforming for the blue hydrogen. The main problem of that one is while generating the hydrogen itself, it will emit a huge amount of the carbon dioxide. To minimize that one, so instead of steam reforming, people are using for the electrolysis and cracking technology. So this is already PEM water electrolyzer of speaker is a previous speaker is explained. So here we are passing the water molecule and it will come and it will approach to the membrane, and at the membrane electrode assembly, this H2O will split into the H plus and OH minus, and that H plus will come, this red color H plus will come. So it means we can call it as a proton exchange membrane. We can call H plus as a proton. It is exchanging through membrane. That's why we can call it as a proton exchange membrane. So that once it will cross and H plus combined with another H plus and it will form an hydrogen storage. So coming to this part where the membrane from the DuPont, this is the company from 1965 onwards till date, there is a monopoly across the globe, is the only supplier of the Nafian supply. So now people are releasing and there is a huge number of alternative people are working to replace the Nafian membrane. Nafian is the standard membrane from 1962 till date. So for the PEM electrolyzer application. So in addition to this, many of the material chemistry people are working in India across the globe. So here we are using the noble metal catalyst like a platinum, palladium, iridium, ruthenium catalyst. So they want to replace this platinum, ruthenium catalyst with other materials like a non-noble metals. So the because of the Ukraine-Russia war, that Ukraine is the main supplier of this ruthenium-based catalyst or iridium-based catalyst. Now the prices are for past 2 years, the prices are increasing like anything. So we cannot adapt the technology. So we have to develop alternative technologies. So this is the basic mechanism, and this is the main advantage of this PEM water electrolyzer or AEM water electrolyzer. It is easy to maintain or easy to operation. So if it is maintain the conditions as you previously mentioned, that you can operate around 80,000 hours continuously. So without disturbing the thing. It is a direct converter, so it means there is no byproduct formation is there, and it is a good return of investment is there for the things, and it is really energy safe and safe in operation. Unlike a battery, if there is a leak or it will contact with that oxygen or atmosphere, it will blast. But here nothing will happen, and there is no movable product in the water electrolyzer, whether it is a PEM electrolyzer or AEM electrolyzer. And for this one, people are replacing that platinum catalyst are using platinum, palladium, ruthenium, beryllium. These are very expensive catalysts. So if you want to replace this catalyst, many chemistry people are PhDs who are working on this catalyst development. These are the basic properties. I am not going to brief about it. So you have to take, you have follow, these are the tick marks. If you want to test your catalyst into the real-time application for the any electrolyzer part, whether it is a PEM or AEM or alkaline, or direct methanol fuel cell or fuel cell stack development. So it should have a high surface area, high good conductivity, and good electrokinetic properties, and long-term mechanical and chemical stability, enhanced selectivity, availability, and low cost. So availability means it is the indigenous you have to develop, and has the safe. So the main challenges is the most we are at present we are using is the noble metal catalyst, and these are very expensive, and that we cannot depend on a single source for this catalyst part, and these are the limited resources. So that's why the main use of this one is in all these catalysts people are using the carbon support, and they will replace the noble metal with the existing or non-noble materials. And these are the one technology where electrolysis is the one technology where green hydrogen will be generated. Other technologies are cracking technology. This is completely depend on the liquid bed reactor or fluid reactor, where if you pass the methane, it will directly generate a carbon nanomaterial under the high fuel rounds. High fuel means it's a fuel cell grade hydrogen. So we are getting, this is a basic chemical reaction, where if you pass the methane at the end from the source, and it will at the high temperature during the in the presence of catalyst, the hydrogen is a lightweight molecule, and it will come outside, and the carbon molecule will deposit on the surface of the catalyst or walls of the reactor. So this is the methane cracking technology, where this bio-CNG or CNG or methane or ammonia. So like it is once you transport the hydrogen from one place to another place, where in the on-site hydrogen generation. So we can call this one. This is also one of the future technology people are looking at on this cracking, methane cracking or ammonia cracking. It is also similar to electrolyzer. We have similar advantage. Whereas in the PEM electrolyzer, the main advantage is still date in India, we don't have the membrane and the quantity of the catalyst. So whereas this methane cracking technology, 100% we can indigenous catalyst. And this is the hydrogen application. Right from this is the next one. Is the Oman government, they approached us in 2023. 2 years back, they want to go for the net zero building. So net zero building means daytime they took the power from the solar, and nighttime they took the power from the fuel cell. So it means the building which is independently grid power independent of the grid power, that building we can call it as a net zero building. By 2047 or 2070, people are looking for the net zero. Net zero means that is the particular system or the particular building is completely independent on the grid power. That building or that system we can call it as a net zero building. And already the main advantage is in that they have a lot of deserts and these places. So you cannot take the grid power from that particular location to the particular homes. So that they want to build their own houses with the net zero. And this is the many refineries or fertilizers industries, steel industries, cement industries. They want to replace pharma industries with this hydrogen, and what the existing hydrogen they want to replace with this green hydrogen. And already that buses for this transport application. And already I discussed about the cell phone towers. all the cell phone towers in India is more than 1 million towers. We have all are run with this diesel generator, and it is very difficult to each time to has to replace. So we can replace with the fuel cells. So these are the one application. And what needs to be done for succeed in the green hydrogen means the first one is cost has to reduce. So like and adaptability. Like in 10 years back or 15 years back, 1 kilowatt solar is nearly 3.5 lakhs is there. Now it is we are getting around 60 to 70,000. So 1 kilowatt. It means the adaptability is there, usage is there, technology develop is there. Automatically the cost will be reduced. Like that in the present green hydrogen, 1 kg of hydrogen is nearly fluctuating around 4.44 to $4.5. So we have to bring into the $1 and usage of the unlock the domestic demand of the green hydrogen. So that domestic demand means where you blend the hydrogen into the CNG or blend the hydrogen into the cooking stove. Last week we are into the Delhi, then that green hydrogen conference. Few of the companies they displayed that hydrogen based stove. So these are it will give a lot of advantage and tap into the green hydrogen export. You can generate more amount of hydrogen and you can export to the other countries and many of the PLN schemes. In Gujarat itself, many of the plants like recently that Adani and there are plants in Reliance, they put a 1 megawatt electrolyzer, indigenous development electrolyzer to PLI schemes. And already the previous speaker discussed about the India roadmap where we can create at least 5 million metric tons of green hydrogen production under the National Green Hydrogen Mission, and it will create 1 lakh, 6 lakhs jobs and import savings of 1 lakh crore. And well, because our energy market nearly for 1 lakh, we are nearly working on 70,000 crores of energy we are procuring from the your importing that we can save it or we can minimize it. And these are the technologies showcased at the various platforms. And last 3-4 years, we have visited many places. And this is that Nitin Gadkari launched India's first green hydrogen vehicle. And 2 years back, he came to that Toyota Mirai vehicle to the parliament. And this it is completely run with fuel cell vehicle. And Jitendra Sharma is unleashed the first green hydrogen bus with. And there is one institute called CSI Sikri, Karaikudi, and KPIT. They developed this hydrogen bus. And we went to the hydrogen conference, and he is my colleague, Dr. Nagamahesh, who visited his Tata Mirai stall in this one. And recently, that AE also, we are part of this Skill Council Grand Jobs and Hydrogen Valley for AP and Telangana. So, where we are recently visited this one. And a few of the buses already in the bottom, the IOCL and this right side part, recently, that 1 month, few months back, they opened the first trial run for hydrogen fuel cell bus in the Ladakh, and it is a Kerala that ferry completely it is a run with the hydrogen ferry they inaugurated, and this is the left one. This is a hydrogen trial. It is I think you saw the videos in the few weeks back. It is a hydrogen based trial runs is done in the Chennai coach track. So these are some technologies they are looking, and that is a 1.5 megawatt electrolyzer stack. Some of the companies are showcased. So these are the technology development, and these are the product across the India. It is already started the green hydrogen project and this thing. And in addition to this, the what our activities we are doing, I am giving the shot. So we are our started companies. So the main idea of our companies, industry is looking for a product, and academic people, 2 minutes, 4 minutes. So academics they are doing in the 4 walls of the lab. It means basic research, a prototype development, and optimization at the lab. So what it is there in your mind, it is a TRL level, technology readiness level 1, and what it is there in your hand, that is the crossed in the TRL level 9. So to bring from TRL level 1 to 9, always industry want TRL level 9 product. Many of the academic institutions or IITs or CSL labs are they are develop their product technologies in their lab and they are ready to give the technology to the industry. So to bridge between the academic and industry, we have the nanosol will develop what industry is required according to their inputs. We will create the facility and according to the inputs from the particular professor or something. And we are also part of this skill council green jobs, and we are also part of the creation of the testing facility, and we will give the complete training for the upcoming industrial academic people. So these are the basic areas of A electrolyzer, whether it's alkaline, PEM, or AEM, and fuel cell, CO2 conversion, flow batteries, and these are our capabilities. And these are the systems for real-time applications. So where you are developing your own catalyst or membranes, those who are working in this academic or research, basic research part, so they can test their membranes or catalyst, what is the activity or what is the output of hydrogen we are getting. So we can use these systems. We can indigenously we developed, and you can use the systems by testing your membranes and catalyst. And this is the electrolyzer system, and this is the fuel cell. And some people they want to use for the BTech people are like electrical mechanical students. So 80%, 80 to 90% is the their innovations is required to test the systems. For that purpose, some people they want we will create the facility and they can test on this electronics part, or they can test on the PLS scheme, or they can test on this automation, or they can test on the redesigning the components. So all these sectors they can test by using the existing system. So like that test complete facility we can create in the for a particular organizations. And already I showed that previous speaker told that these are the flow fields. So these are the very costly like that we are saying. So according to this customer design, so we can develop the stacks and we are supplying from single cell, multiple cell, and these are the cells we exported to the Canada, Australia, as well as the New York, and other many places we are exporting. And these are the huge number of coatings are we done. I have more than 15 years of experience on this. Various coatings like neobium coating, gold coating, platinum, nickel coating on the various plates. And these are the different stacks we exported in India and as well as that various countries. And these are the gold coating. For example, this is what it looks like. This is the current collector. What he said in the previous, it is the copper. We are coated on the gold coating or platinum coating, so it will minimize the corrosion resistance. So some of the people directly use the metal content. Some of the people they want specialized coating to minimize the internal IR resistance. So that type of coatings also will do. And these are the flow battery system for real-time application. And to make a membrane electrode assembly, this is the heart of the fuel cells or heart of the electrolyzer. So we can develop, we can give the compact system where it is the system is exclusively work for to make a membrane electrode assembly. These systems we are exported to the New York, the left side system of its own we are exported, and we are created the facility in India in various places like a fully automatic and this. And this is our 1 minute. It is over. Yep. And this is the demo we gave to the in front of this Government of India Chief Secretary in the Telangana Redco for inauguration of this water electrolyzer plant. And this is the gas electrofermentation like biohydrogen generation we gave to IICT, one of the CSR lab in Hyderabad. Is the NEERI director and IICT director is inauguration of the plant. And across the part of the skill council grant jobs, and we gave across India many presentations and the client manpower and all these things. And these are our organizations like RMIT Australia, Calgary, Hardwell, and Kathmandu University, and many IITs and CSR labs. We are exclusively work with this hydrogen related and fuel cell related project. And with this one, I will thank you for RK Singh sir for your kind invitation and to the